Hi, I would like to show you our compact power factor corrected LLC resonant power supply for EV two-wheeler charger applications. With greater than 94% end-to-end system efficiency, this design features constant voltage and constant current mode control. It includes our CAB03, Hyper-PFS3, Hyper-LCS2 chipset, and our InnoSwitch 3 EP ICs. Available as a reference design kit, RDK-1063, this design features a wide input voltage range of 170 to 280 VAC and a wide output range of 26 to 60 VDC. It also achieves 720 watts of output power at 60 volt 12 amps. Here we have the CAB03, which is a zero-loss automatic X-Cap rapid discharge IC, Hyper-PFS3, our CCM Boost PFC controller, the Hyper-LCS2 chipset, which combines the Hyper-LCS2 half-bridge device on the LLC primary side and Hyper-LCS2 SR on the secondary side. And it also has our 900 volt InnoSwitch 3 EP flyback switcher IC as the auxiliary power supply. Here we have the AC input with the EMI filter section, which is then rectified by the bridge to the power factor correction stage. The Hyper-PFS3 integrates a 600 volt MOSFET, a controller, and an ultra-low reverse recovery Q-speed diode. The Hyper-PFS3 is built into a single low-profile power package. This eliminates external current sense resistors and the associated power loss due to its internal lossless sense FET. And it streamlines your EMI filter design to easily pass EMI requirements. Now let's have a look at the LLC section. The Hyper-LCS2 half-bridge incorporates two 600 volt MOSFETs with a controller, level shifting, high side and low side gate drive, fault reporting, and robust protection features, all built into a single package. The exposed ceramic pad here attaches directly to the system enclosure to optimize the thermal performance and minimize the production cost. Here, the Hyper-LCS2 SR chip combines the main controller and 4 kV reinforced isolation using our proprietary FluxLink technology. This eliminates the need for an optocoupler between the primary and secondary sides. And the Hyper-LCS2 enhances system efficiency with built-in SR management. Customers have the flexibility to use either a fixed configuration or an MCU and a CAN daughter card that is equipped with a DAC or PWM output. In a fixed configuration, the CCCV thresholds can be set using the variable resistor provided on the main board. This configuration defines the default charging. In the MCU and CAN daughter card configuration, you can dynamically adjust the reference voltage, enabling real-time control over the CCCV charging behavior to control the set point for a 60 volt 12 amp output. This reference design allows designers to build a compact and portable EV charger with better than 94% efficiency. If you'd like to evaluate RDK-1063, please contact your local FAE or Power Integration Sales Office. And for more information on the board, please visit power.com.